Okay, so this here is supposed to be a review of the representation of mathematical object called vector and matrix. You will need that a lot. Okay, you need that. Now, of course, the thing that you will learn is matrix multiplication, right? AX. Okay. So something like this, you should be able to recall from your class. Okay, right? And match the dimension, right? In this case, by the way, this is called quadratic form. I don't know if you know, but oops. Okay, quadratic form. Good. It doesn't do other line. Okay. Right. Okay. So you get this, right? So basically, if I go back to this picture, okay, I can have a matrix that looks like this multiplied by this, right? Now the end of the object is going to match this dimension with that dimension. And so I can also multiply another thing. It's going to match this dimension with that dimension. Okay. So what's going to happen? It's going to equal to a scalar, right? So there's the 3 row, 5 column. There's 5 row, 1 column. So let's say 3 by 5. And this is 5 by 1. And this is 1 by 3, right? 3 by 5 multiplied by 5 by 1, you get 3 by 1. 1 by 3 multiplied by 3 by 1, you get 1 by 1. Okay? So what's this guy? This is a matrix. This is a column vector. This is a row vector. This is a scalar. Okay, I'm not gonna, well, maybe I'll type. Row vector matrix vector or column vector. If I say vector, it's vector. You don't have to say column. And this is scalar. Okay, right? So this is something that you learn presumably, and you can keep going. But now we have this. Okay. Okay. Now, you guys know what the screen you're looking at, right? You're looking at. If you think about it, the value of the pixel, okay, has 2 dimensions. So you can think of this is 1 row. Can you see my mouse? Okay. This is another row, another row, another row, another row. It has about 900 rows, and it has about 16,000 columns. Okay. So think of your computer screen. Computer monitor or screen, okay, has resolution, say 900 by pixel, right? Resolution. What does it mean? It means you literally have 900 row, 1,600 columns. But this is a black and white. Okay. Versus RGB computer screen. Now, instead of it has this many big pixels, it has this many RGB values. Okay. As black. Let's see. What's the black and whiteness? It's called brightness. Okay. Now you have okay. But you have to know that each RGB is a triplet. Okay, hence 3 vector. Okay, so instead of thinking of this as an array, a table, you can think of depth. So you can think of hence 900 by 1600 by 3 tensor. Okay, so hence matrix, hence tensor of see that a black and white screen has value associated with each point, but an RGB screen has 3 values associated with each point. So it's actually what's called a deeper matrix. It's called a tensor. Okay, so you have to think of 7 scalar versus vector versus matrix versus tensor. Okay, scalar versus matrix versus tensor. Okay. So this is a thing you have to learn today. It's a little bit tedious today, I have to admit. Okay, but this is where this is the basis of all your work. So this is all going to be under what's called language primitives. So let me collapse this. All this, okay, all this is under language primitives. Okay, now this is where the fun begins. Okay, the fun begins by user-defined function, and this is where you are going to do it, right? So you recall something like sine, cosine, exponential function. This is all built in, right? And then it's not only built in Mathematica, it's in mathematical, right? All the mathematics. Now this mathematical built-in language is based on a lot of those and additional operation like plotting and showing colors and playing video and all kinds of stuff that you saw in the demo video we saw earlier. But now you are going to customize. You're going to customize. Okay. So let me show you a simple example. Let me show you a simple example. Let's say this is a sine function, right? The sine function, x, right? This is the sine. So yeah, it gives this. So this is mathematical function. mathematical function. Okay? So from mathematical function, oops, let me put it under here. Okay? You have mathematical function. Now you also have mathematical built-in function. For example, in this case, I'm going to show you a function that is not mathematical but graphic. So let's plot. Plot what? Plot sin x. From minus to pi. Right? Right? So this is a built-in function. It's built-in function. Now, what if, okay? What if you wanted to make it your function? Okay? You can say something like this. Okay? My sine plot. Now, this is your customization. You want to say, I want to customize this. I want to go from A to B. Sine plot from A to B is equal to this. Right? Now, obviously, you just define it. You haven't done it, right? So I'm going to call this function my sine plot. Okay, my sine plot. Well, let's put the same argument. See if I get the same thing. Same thing. Okay, same thing. So this is the 3 level that you should learn. Yeah. Again, there's a mathematical function you learn in high school or you learn in your math class. There's mathematical built-in function that you would learn, and the one that you use often, you will memorize. But if you don't memorize, let's say I want to use cosine function. How do I do that? Just type in cosine. Oh, it suggests COS. That works. That works, right? So that's a built-in one. Now, the one that you define, just remember for now that the argument has to have a little underscore, and you define it like this. In fact, you can do it this way, but there's a reason why you should do it this way. Okay? And then when you do it later, now you can do that. Right? So let's say I want to make minus 10 to, now it becomes different, right? See? So you don't have to rewrite. Now, this doesn't look like a lot of labor saving because it's just one line. But in reality, this function, instead of having one line, you're going to have a whole bunch of lines. Yeah? You're going to do a whole bunch of things. Yeah? Yeah? For example, let's, yeah, you can do a whole bunch of things here. So this is basically how you make customized function. This is how you make mathematical or program do things for you. You use both built-in and built-in that represent universal function. So this is going to be very long in reality, well, not very long, because it's a high-level language, like I said. Okay? So that's that, right? So you can see that this is interesting. Now, not only can you do this, okay? How about this? I make it a little bit more interesting. Okay. This is not that interesting. What if I want to plot cosine function? So I have to do this, right? Right? That's not, that's kind of, so I have to do this again. Okay, you have to do this. Right, that's my cosine plot. But, well, what if I cosine? What if I want to say my plot, and I write this name of the function, and I put it here. Okay. Now I can supply the name of the function as my argument. Okay, let's see if this works. Plot sine and cosine side by side. See that? In fact, I can plot other function. exp, right? So I can do this. Okay, so I can actually put in this function or that function. So this is how name function works. This example, yeah, I'll just put this example in here as well. So there's another example, is Pythagorean theorem. Put in x and y and do this. Okay, so these are all silly little functions that once I program it, I can call it. Okay. Okay. That's easy, right? Now, this is more complicated version of a function. It has module, it has bracket, it has if, it has then, it has toString. So you can see that this is a lot more complicated than this. But it's the same principle. Okay? It's just computing vector norm, except there's a fancy check thing. So 0 isn't positive, so you cannot compute norm, for example. Okay? Now, yeah, you guys tired yet? I think you guys are pretty tired, but but this is kind of this is it. Once you get over another shot, you be all set. Okay, and I'm gonna stop. After this, I'm gonna stop. Well, actually, I'll skip this and I'll come back. So this is the plotting function, I guess. So now the plotting function, okay, you can do this, right? Plotting function we did before, but you can also add some kind of feature formatting. For example, I can add plot label. Okay, so instead of plotting one thing at a time, I plot two things. Add the label, plot style. So this is something that I want you to be able to play with. Okay. Now, finally, I can plot in 3 dimensions. Okay. This is something like this. It's very easy. So basically, it's sine times cosine. Okay. So that's it. That's all I want you to get today, in terms of language primitive. We are going to go to here next class. We're going to go to here next class. What I want to do right now is go back to here a little bit and Natkap, where did we stop off?
Pardon?
Where did we stop off in the sheet? I think we stopped off some kind of here. So this is a change of pace. Now, okay, let me just stop share for a minute and talk to you guys. Right. You saw in the beginning how easy and at the same time powerful Mathematica platform is as a way of allowing you to play with data. Okay, whereas things like Excel only deals with numerical tables. Python can deal with variety of data, but you need to load different varieties of ways to deal with it. With Mathematica, it's a single thing. Whether or not it's a number, it's a vector, it's a text, it's a piece of text, it's a set of numerical values or pictures or videos. You can import it. Okay, just put in different last name. Say .csv for flat file, .wav for waveform table, right? .jpg for JPEG picture, JSON for app instruction. You know, when you communicate with app, if you want to prototype an app, you have to show that it can take input from the user. Now, when the user enters some information or instruction, you know, it tends to work with what's called JSON format. So Mathematica deals with that too. Okay, so it's very powerful. But before you get anywhere, you have to understand, to get Mathematica or Python for that matter to do things for you, you have to instruct the steps. Okay, so instead of telling Mathematica to do this and that, you have to say, I'm going to define a function. The function does this and that. Then when you want Mathematica to do it, you just tell the Mathematica to call that function. Okay, right? So again, if you're going to tell your mom, ask your mom nicely to say, please make me an omelet. Okay, you can ask your mom to please make me an omelet. That's called declarative. You just express your desire. Your mom is very intelligent, knows how to make an omelet. Now, if you tell your brother to make an omelet, you have to say, step 1, take the egg. Step 2, crack it. Step 3, stir it 30 times. You know, all kinds of stuff. That's called procedural programming. Okay, functional programming, which is the main way you deal with data analytics, is to create function that process the data. It's a function that say crack an egg. There's another function that say stir an egg with n times. So to make an omelet, you would call all this function. You call the crack the egg function, you call the stir the egg function, comma, 30 for stirring the egg 30 times. All right? You call the function fry, the result of that, comma, 5 minutes. Okay? This is how you communicate with the computer. But instead of processing raw egg into omelet, you process data into information. And that's what data analytics does. It analyzes data. Okay? Your entire course is data analytics. Okay? Your entire course is data analytics. Now, let me share this screen. I'll go back to this. Distinction. You. Okay, this is called data analytics capability. Okay. So what can you do? Okay. Now, you can use Excel, right? You shouldn't be in this class if you don't know how to do Excel. Let's say Excel. Okay. What can you do? Tabular data, right? You can work with tabular data of limit. Okay. In other words, when you start an Excel file, let's start an Excel file here. Okay. Now, anytime I open okay, let's do this. Let's take this. Okay. Now, this is what's called tabular data. Okay. This, by the way, is a data from Titanic. Okay. So you go down here. Okay. Of the 1,000. Okay. Of the 1,000, there's some from the first class. These are the ages. This is the sex. This is the status. So you can do this, right? You can do this tabular data, but you can do it fairly limited. Okay. How far can you go? That many rows. Okay. It's big. It's a lot bigger than when I was your age. Okay. So it's 1,000,000 rows. And how many columns? Okay. XFD. That's about, I don't know how many columns. So let's search. Let's go to Google. How many columns? Excel. Okay, so we have that many columns. So that's your capability. Now, with something like, say, Python or say Mathematica, okay, you can deal with tabular data of, let's say, enhanced, okay, extended capacity. In other words, because you don't have to open the whole sheet like this, right? You can deal with many millions of rows, okay? Volume in the big data. Hence, big data volume. Now, not only that, okay? So let's say, I'm just gonna say functional program. Generic. So this is called spreadsheet. Yeah, with computer programming. In particular, functional, you can deal with data extended capacity. You can also deal with what? Let me say numerical or symbolic, or say text. You can say deal with variety. Okay. You can deal with text, numerical, text. You can do with audio, video, Scientific. Now, with scientific, with Python, you can't. You don't have the built-in molecular thing. You have to load the library. But with mathematical, you can. So if you work into health area, you need this. So big data means big data variety. Okay. So that's what we want to do. So you need to deal with this. Okay, you need to deal with it. Now, before I go on, okay, I want to focus on this. Okay, focus on this. In other words, something that you think you might be able to do with spreadsheet, you still do better with computer program. So with that, let me go to this thing. Let me go to data handling. I'm going to open a different worksheet. Hold on. Where's my okay. I'm going to play with Titanic data. Okay, this is my Titanic data. Okay, you guys saw it already, right? This is my Titanic data. Okay. Now, okay. So, well, I can also open your student roster. Okay, I can also open your student roster. Now, just something as simple as count unique. Okay, this is Titanic data. This is your student roster name. Okay, so this is what's the name? Oops, sorry. Where are you? There. Okay, class roster. Sorry. I don't know why it's like that. Okay, so let's say I have this. Okay, I have this. I'm just gonna take some of you. Okay. Now, very simply, how do I know that I don't have repeat? You know what a repeat is, right? Means a repetition. So this person appear more than once. How would I do that? Anybody? Anybody?
Remove duplicate.
Right. So you have to do a whole bunch of things, right? Well, in recent version of Excel, it's a little bit smarter, so it may have a built-in function. But the point is, let me show you this website. Let me show you this website that, okay. So let's say in Excel, count unique in Excel. Okay, I just did this search before class just to show you how to count unique and distinct value in Excel. So if I did this, let me share it, by the way, in the line group, just so you see. It's terrible. You have to do all kind of stuff. Okay, you have to follow all this. Okay. Now in Mathematica, let's say this is your name, right? Okay, let's save as CSV. That's all I need. Student. Okay. Fine. Okay, that's save. So let's see where my scope. Sorry, I put in Excel. So let's put it here. Okay, student. Okay. So let's do this. let's new notebook, no, not new notebook, this is one. I would just go to somewhere here, okay? Import student.csv. Now, before I do that, I have to make sure I have to set directory to notebook directory. This is a little step just to be sure. And my student or oh, not notebook delete, sorry. Okay. Oh boy, that's your name in Thai. That's not good. Okay, I have to change the language encoding, but let's just say, let's just try something else. Let's try this students. Let's use the English name. Okay. Sorry about that. Okay. And let's try again. Okay. Save as. Okay. Now I go back to, don't save. I go back to this and okay, that's it. Okay. Now, all I need to do, by the way, is this. I can count. Okay, count this guy. Okay, and literally it's counting all the unique files. So Honvivat with 84 has 1. So all the entries are 1. So there's no unique, right? In other words, if I want to check, it's very easy, okay? It's just very easy. If this thing appeared twice, then it will be like 5 or something like that. Anyway, so all I'm saying is that, first of all, you can't do that with very large file, okay? And even if by small, you mean less than 1 million, you have to highlight or do this kind of thing, stuff like that. It's very clumsy, okay? So to handle big data, it's better to use computer program. That's what I'm saying. That's what I'm saying, okay? But now, let's go to the next step. Let's go to the next step. Okay, let's go to the next step. Let's go to what's called a data. Now, this is where I want you to have individual homework, okay? So in Mathematica, there is a function called example data. In other words, these are same pre-compiled data, okay? So in other words, working with structured data. So let me write this down. So this is all structured data. Now, this is not one data. These are groups of data. So aerial image will be image. This is audio, color texture, all kind of stuff, linear programming, all kind of things, matrix, network graph, like social network, machine learning data, texture, text, statistics. I want to just focus on statistics. Okay, just focus on statistics. These are all the statistics. Yeah, these are all the statistics. There's a lot of them. So actually, if I want to see how many of them, I just say length. There are 111 statistical data. So I happen to notice this one I like called cabbages. Okay, I'm just making this up. I'm just taking this one. Okay, so this cabbages has all these properties. The one that I'm interested in for now is just the name, the column heading, okay, and the data element. Okay, this is it. Okay. This is data element, just for some reason, okay. and I'm just making a data set out of it. And so this is my way of showing that even though this is unlimited, fairly unlimited, it can be huge, okay? By importing it and converting it into what's called a data set object, it looks just like Excel, okay? It looks just like Excel, except it can deal with a lot larger. Well, in this case, it's only 60, right? So it doesn't look like there's an advantage, but there is an advantage. Okay, it's only showing you 60, but it's not limited to 1,000,000 the way Excel is. Okay, so you can deal with much bigger, but at the same time, you can view it the same way. Now, what can you do with all this? What can you do with all this? I want each of you, okay, each of you to select a data set. Now, I have done this for you. I've done this for you. So this is example data statistics. Okay, this is all the names. It's basically the list of all that, right? And I'm just gonna arbitrarily. Can you guys see this? Right? Okay. I'm just gonna put in some random number. Okay. First of all, cabbage. Okay, I'm going to eliminate this guy because this one is going to be used for example. So no more cabbages. So this is data set. Okay, I'm just going to make some kind of random number. Yeah, you can do this with Mathematica, but I'm just going to. Okay, so this is my random number. Okay, I'm going to just make this a table and I'm going to sort data. So again, you can do this in Mathematica, but I think you guys are so now. Okay, so first of all, easiest thing to do is to make it into a table. How do you do that? Format as table, right? Oops. Format. No, that's not good. How do you format as table? I think that you can do that, right? Oh, I have to save it as Excel first. See? Okay, so I have to make it into an Excel first. Okay, and let's see a format as table. Okay, I can do that. So let's say this is my data set. Okay, and I'm going to rank from smallest to largest. So now it's completely random, right? And now there are 100, there's 55 of them. So let's go to 56 and okay, so that's that, good. Now I'm going to make this. Okay, this is my random assignment. Okay, let's go back to you guys. Where are you? Okay, this is you, right? Okay. So this is your assignment. Yeah, this is your assignment. Yeah, this is your assignment. Your assignment for next class is to go to here, use your function, yeah, example data. Okay. But instead of doing this, instead of cabbages, you would say, okay, let me have one person. So let's say you happen to be picking stack loss plan. I don't know, slack loss plan. I don't know what that is. Yeah, that's your data. I don't know what that is. Okay, I don't know what that is. Okay, it must have some kind of properties. Okay, and so this is the data element. This is column heading. So airflow, water, whatever. I don't know what it is, right? Okay, so that is your data. So this is your assignment. Your assignment is to go and load. For example, if your name is Poon Vipat, you load university salary and this. Okay, this is already randomized. Oh, got more random. So there's no Great Britain auto debt. Okay, you have more. Wait a minute, we have more students, right?
We do have 55 people.
55, yeah. Where was that file? Where was that file? Sample students. Yeah, where's that file? You just did it earlier, right? No, 48. Yeah, where's that Excel file?
Actually, I have the
You
update
have?
one.
Okay,
Yeah.
okay, fine.
It's
So
okay.
this is it's kind of weird. What's kind of weird? So I did update it, right? I did update it. You guys in the beginning of the class. I don't know where it is. Maybe I erased it somehow. But there it
Maybe
is.
this one.
Oh, yeah. Okay, good. Okay, so there you go. Okay, so that nobody is working with KLDDT and formaldehyde. That's okay. It's kind of different.
I will give you more. I have 55. I think that some people not.
More?
But anyway, let me check it first.
Okay. Okay, Cap. So that's your homework. Your homework is, this is who you are. You have to go load this data. Now, what can you do? What can you do with it? What can you do with it? Right? Now, let's see what can you do. Well, let's look at this example. Okay. I have this Titanic data. So if I have this Titanic data. Okay. So let's show what Titanic looks like. This is my Titanic data, right? So let's put that in table form, right? Class, age, sex, status. Okay, so that's it. That's all the data. So there's first class. Okay, so by the way, if this is so big, Mathematica would just give you sort of like abbreviation to say, you know, it's too big to load or something, too big to show. Okay, so anyway, that's it. I have that, right? Now, what is it? Because Titanic is a list of lists, right? So you can think of this as the first row, second row, third row. So what if I want the third row? Okay, third row is apparently a baby because it's not even 1 year old. So let's see. Bracket, bracket to access, right? 3, bracket, bracket. That's the third person. Now the last person, how do you access the last person? How do you access the last person? Well, you access the person who is the last guy, right? So this is the last person because the length of Titanic, what's the length of Titanic? Oops. Okay, there are this many people, okay? So the last person is this. Or alternatively, you can say counting from -1. This is the same thing as yes, it's the same person, right? So this is a third person, this is a last person, okay? So this is how you access. Now, all I want you to do, okay, for homework, this is for homework. And again, we are working with very simple data, right? Very simple data, just class, there are only 3 classes, age, sex, 2 sexes, and 2 status, died or survived. So this is very simple data set. Okay? Now you will be working with your own data set. What you would do is, well, for example, something that is numerical, right? But first of all, let me go to that addressing a little bit. So if I want the third row, it's this. But what if I want this? The second column, so it's 3, 2. Okay. Now, if I want all, I just put in all. See, it's the same thing. So my question is, yes. So if I don't mention which column I want, it's the same thing as I want all column. Okay. Now, what if I don't want all the columns? I want the second column on. In this case, you use something like 2, comma. Now, if I do this, so let me try this. Okay, 1, comma, and you know it go up to 4, right? Okay. Now let's try again. Let's get from 2 to 4. From 2 to 4. See, second to the fourth. How about from 2 to 3? Right? How about from 1 to 3? Okay, right? Or how about 1, 2 to all? How about instead from 1 to 3, I just say blank to 3. It's the same thing. So I want you to show that. I want to show you that this is the same thing as that. This is the same thing as 1 to 3. Okay, let's say 2. Okay, and let's say 2 to 4 is equal to 2 to 4. Or so by omission, it means goes all the way. That's what it means. Okay. If I don't say, so all these statements are true. Take the third row, all of them, or from unspecified to unspecified. It's the same thing as all. Okay. Take the third row up to second column. So same thing as first and second column. Okay. Let's make it the 7th person. So this person, fifth person survived or not? Die. That's a bit depressing. That's this one. Let's find a 7th person. Ah, okay, lucky. For your homework, yeah, which is due. Let's make it due tonight because it's kind of easy. Okay. For your homework, all I want to do is pick up some number like this, and there's going to be like numerical files. So let's say this one is age. So I'm going to say histogram. Titanic. Okay. Titanic what? Titanic what? Titanic second column, right? All 2. Now it's very clever. It knows that the first one is a name, so never mind. Okay. So this is it. This is a histogram. Okay. Now, by the way, if you want to know about how to fit in Mathematica, I want to fit the histogram. Mathematica fit distribution. Okay, find distribution. So let's see that. Find distribution. Oh. Sorry, in this case, I have to omit the beginning because the first one is a name. This one is no. Format. Position 1 does not have. Oh, okay, sorry. No? Ah, okay. You can't do the fit the distribution because there's some empty. Okay. So we have to replace this with empty. Okay. 0 with now with empty. Okay. Yeah, it's a little bit tricky. Hold on. Okay, so there's some empty file. Oh, sorry. I have to deal with empty. Okay, hopefully you don't have that. So, your example, go look for some simple one. For example, we have to eliminate empty. I kind of forgot because we only have 2 minutes left. How to eliminate empty. There's actually a very quick way of doing this. I kind of forgot. Okay, not I kind of forgot. I don't know yet how to do it, but it's doable. Okay. Okay, so all of this would have what's called a data. Okay. Now you can do 2 things. I want you to do 2 things. So this is your homework. Homework. Where's your homework? Where's your homework? Where's your homework? Where's your homework? Okay. 9. Homework. Go to use example data to download your data into your Mathematica notebook. Okay. Now, this one you don't have to you don't have to just memorize. In your data sheet, do this. Okay, into another thing. Okay. Okay, put in this command. Okay, and then what you want to do is write and read. In other words, export. And import back. Okay. What I mean is, Okay. What I mean is you can import the data. So let's say I did this, I import. Okay, I import. But in your case, you would actually use example data. So you can export as well. So let's say export. Okay, export. Now, anytime you don't know how to use a function, just put in first one. Okay. So I want to export Titanic to my output file .txt.csv. Oh, because okay, this is a problem specific to me. I use bracket for my directory, so you know it's a bit messy. But so use import and export function. Okay, so use import and export function. Yeah, this is something I did that's not very good. I use a bracket that you know Windows doesn't like. I shouldn't do that. I use bracket for my thing. Okay, but say I have something like this. Yeah. Okay, I can do this. I can say new. Okay. Fine. New notebook. Save as, and I'll just go to the top. Okay. Now this one I can do easier. So set notebook. Okay. And import. What's the name of my file that I put on the top directory? Something like that. Okay. Okay. And you want to see okay. So something like this. Okay. So I have this now. So if I want to export to output file. Okay. There's something weird about me for some reason. Now, for some reason, I can't write output. But you shouldn't have any problem. I think I have some kind of silly stuff. Anyway, my apology. So first thing I want you to do as your homework is to load it and just practice importing, exporting. Okay. So there are three functions that you need to play with. Okay. And next week we'll start to play something with it. Okay. So each of you will have two data sets according to this that you can play with. And this will become your personal project. Okay. So this person would work on Mark Twain and Fly Ash. This person would work on SP100 and CPU performance. Okay, that's okay. So if you have problem with import, export, it's okay. I have problem too. I don't know why. I think I said something funny. Okay, but you should be able to have this and try to play around with accessing. Okay, so it's like this. If you have the data, and I want to get the fifth row, okay, to the 10th row. Okay, so the fifth row, so forth, right? Okay, so this is, and play with this, play with table form. Okay, so that's all I want to do. The homework is for you to have this data. Okay, once you import it, just save it under this name. So if your name is this, save it under homework. Okay, homework 1 underscore 8 whatever .mb. Yeah, so this is, let's say this is your name. And submit it. Submit it. Now, if you are able to write and import back, that's good. Okay, so do this. Okay, but basically show me this, that you have two data sets. So what you would have is you would have one data set and two data sets. Okay, does that make sense? Okay, let's tell you what, I'm going to give you the cabbage example for you as a template, so you can play with that. Okay. So that's here. That's here. Cabbage, where's the cabbage? Where's the cabbage? There, cabbage. So the cabbage data, right? I'm going to do this. I'm just going to do example data. So for example, my data, you write that into your line. Data 1 is equal to, say, this. Okay. And data 2 is equal to something else. Something else. Okay. But don't just do this. Follow through the step here of checking the data. Okay. Find the statistics. Now, some of you may want to play with non-statistical data, like you want to play with color, audio, video, picture. There'll be time for that. Okay, there'll be time for that. It is a big data course, so you learn with different kind of data to play with. But right now, just focus on statistics because it's most familiar to you. It most looks like a spreadsheet. That's what I'm trying to say. Okay. So focus on that. Homework. Okay. Okay, so this is your class 1 side note. This is a class 1 side note, but you will have the full mathematical note here. Okay, so I'll give you this as well. Save as class 1. Note. It's really weird. My Windows allow me to save notepad file in bracket, but not the other form. Right, so this one I don't need to save. This one I save, and I'm going to give to you. Okay, so let me stop share right now because we run a little bit over time. Okay, sorry, it's a little bit it's a little bit hectic with me saving under the bracket, but that's not mathematical. That's just me and Windows. Okay, it's a weird thing. Okay, so any question?
You didn't tell us how to submit it.
Yeah, my course view. Okay, so submit it to my course view. Now, I want you to submit this evening because the earlier my TA see it, the more the feedback he can give back on how to help you guys. So if you have difficulties or whatever, by all means, okay? So the course view you can submit the file. I think you have to zip it first or maybe not, I don't know.
We should zip it first before submit the file.
Zip and submit.
It should be okay.
Now, again, don't use funny names. Just use homework 1 underscore and your 5-digit. Okay. Okay. As the name of your notebook. Okay. So submit your mathematical notebook. It's so light that you would have no problem whether or not you're working on a full version or reduced version. It's very small. Okay, it's very small. Okay. When you go to example data for the first time, it would actually go to a repertoire of data set, and that may require you to have sort of like a login. So you might have to create a login. So that's going to take a little bit of time. And use your Gmail, whatever account. Okay. So just be aware of that. So that might take a little bit of time. The first download might take a long time, and the second and third download is very quick. Okay. So once we did this, what happened next Wednesday? Next Wednesday, we'll start to play with the data. Okay, we'll start to play with the data. Each of you will have different types, but all of you will have tabular data. So there'll be some common scenario, okay, common features to the data set. It won't be the same, and but it will be similar. Okay, so next week it's going to get more. Actually, it's going to start to become fun because you start to play with something. This week is a little bit harder because it's, you have to learn the primitive and then you have to prepare yourself. So this class is really a preparation for whatever comes after. Okay. So with that, if you don't have any questions, I'm all good.
When is it due?
Not 2 ทุ่ม no?
Today?
Yeah.
Okay.
Okay,ครับ. Yeah, so submit it. I think maybe from Peanut's gonna make a submission right after class. Okay, so okay,ครับ. You guys, all of you presumably have your own private email and stuff. So use that if Mathematica asks you to create a user. Okay, so you can access the data. It's free. You won't have to pay because you already have the software. Okay.
Ajahn Krab, I think maybe can it be tomorrow because some of our students have no activation key yet. I did ask.
So what? Actually, you should have that already.
I did ask because there are new people coming.
Okay, fine. Okay, so I'm going to give you guys the files and the notebook as well. Okay, for this class. It should be put on course view, but just to make it easy, everybody's online, right? Okay, it's a little bit. It takes me a bit of formatting to put things in course view. So to make things easier, I just put the notebook and notes online. So presumably everybody's on that, right? Okay. So let's make it tomorrow 5 o'clock. Tomorrow 5 p.m. Okay. Okay, very good. Okay, Cap. So with all that, I'm going to end here. You can follow again the data from the tutorial spreadsheet. I will have that. And okay. มีอะไรไหมนะ
มีน้องคนหนึ่งอยากปรึกษาครับ There are a student who want to ask you about the project after this class. Are you free after this one?
Yeah, sure. Go ahead and ask right now because some of you might benefit. Some other people might benefit from this as well.
Okay. Hi, Professor. I just continue asking you about my project that I consulted to you like last week.
So this is the team that wants to do data science as a service using homomorphic encryption, correct?
Yeah. Yes.
Okay. What year are you? Are you in the same year as the other student?
Yeah. I'm second year in, but here's my brother. He is the CTO.
Okay.
Yeah. Let me talk to you.
Okay. So
what's your question?
So we want to get some advice regarding like support vector machine. So currently we are trying to implement a support vector machine optimization algorithm into our library. And normally when you do support vector machine optimization, you would optimize the dual form, which is the Lagrange multiplier dual form, right? But using the SMO method, but for our homomorphic encryption, there are some limitation that makes it impossible to implement that method. So we look into the other method, which is implementing the primal form optimization, and we stumble upon a paper called Pegasus. I'm not sure if you have heard of it or not. It is
Because it's just the primal form, I think.
yeah. So we want to get some of your advice about, like, is this the best way we can do it? Because when you're doing SMO, you need to do like comparison, right? Which is something that is impossible to do on encrypted data because we do not see the data.
That's right.
So yeah, so we think that maybe it might be best to implement stochastic subgradient descent, but we are not really sure if that is like, if there are some other way that is better than this. So we just want to get some
Advice from you,
yeah.
Okay, Cap. First of all, I don't like support vector machine. That's very sad fact. Okay.
Yeah.
I'll tell you why I don't like support vector machine. The reason is the whole reason of trying to do machine learning in a non-statistical way is to deal with relationship that is high dimensional and non-linear. Okay. Now this meaning will become clear to the class. Okay, I'm trying to sort of like use your example to help teach the class as well. At some point, let me just do a hand waving. Let's go to okay, and let's draw a picture. Okay. Okay. New. Okay, so this is let's say two-dimensional data, right? You want to separate. Oops, sorry. By the way, I think next time I'm going to bring in like an iPad. So let's say this is your data. Okay, this is your data. It turns out that you want to separate this group from this group. Okay, so what it means is that you want to separate. So for some reason, this represents cat, this represents dog. So you want to separate it with a line. Okay. Now, up to this point, even though statistical method makes assumption on normality and all kind of stuff, the point is, as long as you can separate left and right using a straight line, you can use logistic regression. You don't need any kind of machine learning. Okay. Support vector machine simply makes this process more robust because it relies less on the normal distribution. It's just trying to create a distance. It's just trying to create a distance. Okay, so that's what a support vector machine is trying to maximize this kind of separation. It's kind of push this as far as you can, push this as far as you can. Oops. Okay. The point of using non-logistic regression, okay, is you want to deal with the situation where you cannot easily separate the data set. So for example, you want to separate this set from this set. Okay, this set from this set. A support vector machine cannot do this. Okay, because just listen.
Okay.
A support vector machine can only create linear separation. Okay, so how do you get around this if you have to? Okay, let's say 20 years ago, you had to use support vector machine. You had to, because neural network, a deep learning algorithm is not advanced or it's very expensive. So 10 years ago, 20 years ago, people had to use support vector machine. for data like this. To get around the fact that you cannot draw a straight line, you can't do this, right? What you do is you create a projection. It's hard to draw a projection here, but there's a projection in a coming up out of the screen. So you create this function that would lift one part relative to the other. This is called kernel trick. Okay. The problem with that is that you have to specify the shape of the function. It does not learn from the data. For example, you have to say something like, I'm going to use a flip sine function. I have to use the exponential function. I have to use a third degree function. I have to use a Bessel function. I have to specify the nonlinear trick just to lift two data sets to be apart. Okay, why did we have to do that? Because in the 70s or in the 80s, machine learning using neural network was very expensive. Okay, it's expensive to do. Support vector machine is much cheaper to do. So that is why they have to invent this kind of kernel trick. It's still not non-parametric learning because you have to specify the function. It's not like neural network where there's a universal approximation theorem that fits any kind of nonlinearity. This is only limited to the linearity you create. And that's why if you're going to do things like, say, homomorphic encryption, where your functionality has to be sort of like embedded because you have to, do the encryption and operation on that and back again, you will have problem with the kernel part, I think. You probably won't have problem with the linear separation part. You will have problem with the kernel part.
Yeah.
So I have not had that much experience with playing with kernel tricks, obviously, because to me, I don't use it all. I don't use support vector machine at all. I would have been using supporting vector machine in the 80s when it was expensive to do machine learning in other method. But nowadays, I've never done it professional. I've never submitted a single professional project using support vector machine with or without kernel tricks. So I have to say that if you have to use support vector machine for some reason that I don't understand, I can probably, well, my advice is to try something else. Okay, sure. My advice is not to work around this with support vector machine because I have not been using supporting vector machine in 10 years. Maybe I see example in school or something like that. But in professional life, I never use it.
Okay.
Okay.
If you ask me for a real advice, I would say try to find a more robust method that does not require you, when dealing with nonlinearity, to specify nonlinear function, which we have problem when you do the homomorphic encryption.
Okay, sure.
Even if you don't have to do homomorphic encryption, I still would advise you away from support vector machine, simply because you have to a priori specify what the kernel function is. And that to me sounds like a very narrow-minded way of doing things, right? It's like if you knew ahead of time that it's separable by a sine function, well, then the problem is trivial, right? But if you don't know ahead of time, how are you going to know? So it's sort of like cats and dogs. So I never like a support vector machine, even with nonlinear kernel tricks.
Is this all the case for the Gaussian kernel, the RBF kernel?
Well, RBF kernel is very nice to compute because you have an approximation function. But the Gaussian kernel function itself is very complicated to implement. In fact, there's no closed form expression for Gaussian kernel. So if you're going to pass that through your homomorphic encryption, you might have trouble as well.
Okay.
But maybe not, because again, nobody works with indefinite integral form of the Gaussian kernel. You work with some kind of approximation. In other words, that Lang Tao, that hat-looking thing, that Napoleon hat thing, the Gaussian shape is actually approximated with numerical algorithm. And so you can say that numerical algorithm, numerical fit algorithm, like spline, that sort of thing, this piecewise nonlinear, can pass through a homomorphic encryption easier. I don't know. Again, I don't work with homomorphic encryption, mostly because in my project, I'm actually allowed to access the data. So if it's a data that's secret, because I'm a consultant, of course, I have to sign non-disclosure and all that. But once I do that, I do have access to data. So it has, I've never had to use homomorphic encryption in my work. So I don't know if other algorithms, other machine learning, like nearest neighbor or whatever, is much easier to implement. I have no experience with that. But again, with or without homomorphic encryption, I have never been a fan of SVM.
Yeah. Okay.
I covered them in class, just to be complete, I think. But I don't even cover that in this class, I think, last time. Okay.
Okay.
So anyway, for the rest of the class, this is like your friend has some kind of project that wants me to ask me done. So instead of answering them in a line group, I ask them to repeat the question here so that some of you can benefit. Okay, so this is sort of like a sharing, knowledge sharing. So by answering them, I'm sort of like hopefully touching on subject that might matter to you. Now, ideally, I would prefer that this question came up later in the class, but I can talk about it now, it's no problem. Yes. So maybe some of you benefit, some of you want, but it's interesting. I do like to help out. Okay, Kap? So wish you all the best.
Yes.
Okay. So that's the okay. So I'm gonna, I think with that, we are way over time. So let's meet again on next Tuesday. By then, I should have like a microphone that will eliminate some of the echo. And maybe I'll bring an iPad and a notepad, something that I can scratch on. So I think that will help. Okay, Kap, Matt,มีอะไรไหมเอ่ย
อาจารย์คะ Can I ask? So later after this class, you will publish in my Crossfield descriptions of the homework, including an example of the deliverables.
Yeah, I'll put in the line group right now because I have to leave. I have to be somewhere very quickly, and my course view takes a while. So I'm just going to put in the line group, if you don't mind. We'll put that in the course view later. Okay. UTA will put that, but right now I'll just put in the line group right now. Okay. Okay. So those two files. Okay. In fact. Okay, Kap. So with that, I'll see you guys on next Tuesday. โอเคนัดเตือนพี่ด้วยให้ make sure ว่าพอสั่งซื้อไมโครโฟนแล้วเทสใหม่ว่ามันโอเคไหมเพราะไมโครโฟนอันก่อนมันไม่เวิร์กเลยได้จ้ะโอเคครับ